Who am I? Wido and Hollander have been working in the hosting industry for 20 years, mainly a Linux techie. Nowadays, I'm a CTO of a large European hosting company. And a bit of my highlights, I can talk about this for a while, but there's Ceph and there's CloudStack on there, which are two things I've been working with for a very long time. And personally, the stuff, everybody puts it on slides, married, two kids, etc., etc. But the organization I'm a CTO of is Your.Online. We're a hosting company throughout Europe. We have multiple brands in different countries, more countries to follow very soon. And as I said, my role there is CTO, so overseeing these organizations with their deployments. But we have very large Ceph and CloudStack deployments powering millions of websites here in Europe. So in the background somewhere, stuff is running on Ceph and CloudStack or mail systems which are running within our private cloud deployments. Bit of referring back to the talk this morning from Ampere. No, public cloud is simply not a solution for us for many, many reasons, and cost is one of them. A private cloud for us is much cheaper than running on a public cloud. But my journey with CloudStack and Ceph started quite a while ago. So back in 2012, I discovered cloud.com, which was then semi-open source. I started working with it, and then it was donated to the ASF. I wrote various integrations for Ceph's RBD. I wrote the integration in CloudStack, IPv6, and for Ceph as well. Back in 2007, I deployed the first Ceph environment. There was no versioning nor a name for it. And I have user number 9 in the issue tracker. So I'm a bit silent nowadays on the issue tracker because my position's changed. And in the past, I wrote the RBD integration for libvirt and PHP bindings and Java bindings. So that's me. But my talk is not going to be about Ceph nor CloudStack. It's going to be about the speed of light and latency. And everybody knows, well, we're encountering the speed of light every day, every second of the day. We have something to do with the speed of light. But how fast is it? Well, it seems pretty fast, right? Right? We can do about 7 to 8 times around the Earth in a second with the speed of light. So that shouldn't be any problem, should it? Right? Why? This is super fast. So no reason for this to be any of our bottlenecks. Why should we worry about the speed of light? Well, it has something to do with the speed of light and how it travels through different optics, cables. And you actually see that the speed of light goes down when it goes into a fiber optic cable. So we go down from about 300,000 kilometers per second down to 200,000 kilometers per second. So it starts getting a bit slower. It's still super fast, but it's getting slower. And why is that? Well, light travels through cables. It also bounces, refracts while it goes through the fiber optic cable. So it takes more time. And what does time mean? Well, does it mean something like latency? Well, probably. But a good rule of thumb is that for 1 kilometer of fiber optic cables, you get 5 microseconds of latency. That still doesn't seem like a lot, does it? A kilometer of cable, that's quite a lot. But that also includes the bouncing and the refraction in the cable. But if you start looking at a data center, you will have endless amount of cables running there. I think this is actually UTP cabling, copper cabling, not fiber cabling, but I found the picture pretty nice, so I put it in there. But you get the idea, there's a lot of cables inside a data center. And anything going through a cable takes time and thus adds latency to the environment. We have a deployment here in the Amsterdam area where we have multiple data centers and we rent dark fiber. And you see these red dots are data centers, and then we have the dark fiber paths. So these guys gave me a KMZ file for Google Maps, I think that's what they're called. So you get these nice trajectories. But you see that this fiber cable here, running from Haarlem, anybody's guess which data center it is? Yes, good one. Yeah. So here in the south, I think this is Equinix AM5. Well, the distance here, there's something in the middle, which they call an airport. So there's no cable. So the fiber optic cable takes this path going from Haarlem to Amsterdam down there. So you think that, well, it's just, you look at it, it's a couple of kilometers. But the path might be even double or triple the actual amount of distance between the data centers. So you get more latency when something needs to travel between the data centers. Not mentioning the cables within the data center, all the patching which happens, which introduces additional latency. So more time, more latency, and you have to circumvent an airport because we're not allowed to run cables through an airport. Latency again, ChatGPT, thank you for this text. Well, otherwise I need to type it myself. But you can see that if you do a ping to somewhere, you get a latency of 1.3 milliseconds, 1.4. Who says that's a low latency? Well, you're about to put up your hand, but then, oh, of course, there's a lot of gotchas in there. You could say if it's your home connection, your fiber connection, and you're pinging Google or something else, it's a low latency. But if you will be running a Ceph environment and your latency between your Ceph nodes is 1.3 milliseconds, is that low or high? That's high. But what would we say which is low? Yeah, 0 point something. And that's where it gets interesting. So these latencies here are internet latencies going, from Amsterdam to Barcelona, all fine for user applications. However, is that true? Is it still fine for user applications? Because latency, everybody has been screaming at their computer or their PlayStation or Xbox. I don't know what your thing is. I started back in the days with gaming with Battlefield 1942. And then you were really trying to find the best gaming server with the lowest latency, because just having a few more milliseconds of latency would kill your user experience because you would die quicker than the other ones would be in the same game server, right? The fun fact is I also had some co-location then, and I was gaming in the data center where I was running my own Battlefield server with the lowest latency. That really gave you an advantage. Anyway, so we were talking about latency, but there's much more stuff than just a fiber optic cable. So this is a Juniper box, and there's an SFP in there, which is, you probably know, converting electrical into optical. It takes time. It introduces latency. Within a data center with multiple cables, firewalls, routers, switches, all where traffic passes through, takes time, introduces latency. And I can continue endlessly with these kinds of things, but you'll simply get more latency. Now, a typical data center environment, how you can set it up. And then we can talk about, we need bandwidth. If I go to a mailing list of Ceph or somebody saying, we need 100 gigs of bandwidth in this Ceph server. Well, do you really? Or do you need the lowest latency? Looking at it is that 10G, even to 100G, the latency is very similar. The jump from 1G to 10G was really big. You really don't notice it that much anymore going from 10 to 100 Gs. Yes, the latency is lower because 25G has a slightly lower latency than 10G, and 100G is often 4 times 25G internally. So you will get a slightly lower latency. There's a great blog post about this where he has more information regarding it. His conclusion is you don't notice it that much. It helps. But we go even further. There's latency within the CPU going to different parts of the memory. If you want to go to the DDR memory in a machine, it takes more time. So applications running in this part of the CPU are much faster than needing to go to the memory or even go to a hard disk or to the network card. It takes time. So latency, latency, latency. I think you get it, what I mean. Multiple CPUs in a system. Actually, the distance between the memory and the CPU starts to matter on high-performance applications. The further away the memory banks are, the physical limitations are becoming a problem. Multiple CPU systems, I try to avoid them with Ceph. You get the NUMA issues, network card being connected to a different CPU, so it needs to go through the interconnect. I would always recommend using the one socket systems. Dell, HP, Supermicro has them, a couple of NVMEs in there, and a single socket system, so the network card and everything is within the same CPU, and thus you are getting a better latency. So conclusion, okay, the speed of light influences latency because it just takes time for something to get there, and we're not going to get the 300,000 kilometers per second, and we're adding more distance in our cables. So, but how do you notice this in your cloud environment? So let's say we're going to be writing something on a disk. So I was writing something on local storage, and I was getting like half a millisecond of latency when writing a 4K block. But suddenly I started writing something with a VM which is on Ceph storage, and I noticed the latency goes to 826 at lowest. Initially, you might say, that's not bad, right? It's not bad. Well, the latency is double than the latency in this case on local storage was. Yes, I could probably tune this machine much better using something, but it's an indication that you already see the latency is double. if somebody looks at the number, if you put it on a graph on absolute, and if the graph would go to a second, they would both be at the bottom. They would both be great, right? But relatively to each other, Ceph performs much worse than a local storage environment does. So the amount of work you can do in a second is half the amount of work you can do with Ceph than you would do on local storage. I often say pick 2 out of 3. So it's cost, quality, performance, and somebody makes a different triangle. You can't have all 3. So if you want to have high performance and super high quality, be ready to spend money. Pick 2. And this is just another thing I found. You see the IP networks, fiber channel, we're going to make it super redundant with all kinds of network connections, but we're going to be paying for it, maybe not in euros or dollars, but in performance, in latency, we're going to be paying for it. Nothing is for free in this world. But let's say we're going to be writing some files in a single loop. All those files, it's latency, which tells you how fast you can write, because the F-write and the F-close, they both take time. The lower the latency on your storage is, the quicker this can be done. And so single queue or single core performance is still relevant in many applications, because a lot of code still runs in a for loop or for each loop. This is a bit of PHP, but it could be Python or whatever language. It still depends on this latency for a single thing. And I was having a discussion during lunch with somebody. If I do a benchmark on storage, I benchmark with a queue depth of 1 and writing 4K blocks. I don't care if you can do a couple of gigabytes per second on the storage. I want to know what is the latency when writing something to the storage, because that really influences a lot of things. So with Redis, yeah, we can have a Redis database on local host. So you have your CloudStack deployment, and you're going to be deploying your Redis on a different server, your SQL database somewhere else, then your web server here, and etc. We're going to be using microservices everywhere, everything on different systems. But keep in mind the latency between the virtual machines, because that determines how quick the application will run. So a Redis server on local host is quicker than a Redis server in a different data center, beautifully distributed within your cloud, but the latency is what, 15 times the amount of latency you would have on a Redis server on local host. And that influences the performance of your application. So this is where we kind of connect to Ceph and CloudStack in the middle with this talk. So this PHP code here, I actually reused a bit of my talks. So I did was PHP for a PHP people. Again, writing these 1,000 keys into the Redis database, it will be much quicker on localhost than it will be on a Redis server remotely somewhere. Even though the 1.5 milliseconds seems okay. Low latency, right? Same goes for a SQL database, client talking to a SQL database, and then you have a VM. If the SQL database would then be again on Ceph storage, yeah, well, super redundant, super safe, but performance-wise, it's probably not the best thing you want, because a lot of queries run in a single thread. So synchronous replication, I think we're all familiar with this. We write to a master, replicas, and then the acknowledgement only gets back when all the replicas have said that it was written. So Ceph works this way if you're using replication. 3, the default, you're only going to get an acknowledgement on your write if all the 3 replicas said, good, I received the data, it's done. Super safe, yeah, but it's not always the fastest. Let's take a Galera cluster, running a SQL database on your CloudStack environment. So you're going to be running Galera, and you say, okay, I want to have this distributed over Amsterdam, London, Frankfurt, super important data. Yeah, latency, and we just saw the table between Barcelona and Amsterdam, or London and Frankfurt. Of course, there are lower latencies, but there's still latency. If you want to write something within this database, you have to wait for the others to acknowledge that they have received it as well. Your performance goes down, your actually safety or quality, how you want to call it, goes up of the environment. So it's a synchronous replication, but then you could say, wow, super awesome. We have Redis, which can do asynchronous replication much faster, but it's eventually consistent. We're at Adyen, a payment provider. So I do a payment, and they use Redis or Elasticsearch. They don't, but just an example. And my payment went through, but eventually it might make it to the replica or not. So your money might go into the void, or it might be there. No, you don't know. So for financial transactions, usually you want to use a synchronous database that the transaction is only approved when it actually was approved by all the others. That means you want to you're going to have latency between your databases, and you want to keep that latency as low as possible. Same goes with Elasticsearch. You can also have eventual consistency. I had a talk a few years ago with somebody who said, no, we're going to be using Elasticsearch to store our invoices much faster than a SQL database. We're going to be creating JSON documents and putting them in the Elasticsearch is much easier. I said, no, we're not going to do that. And but he just couldn't wrap his round around the fact what consistency was, eventual consistency. But this is something you see with developers. No offense to developers, but yeah, you need to understand why you're going to be using a certain database for what. But by then, Elasticsearch was on the hype curve. Everybody was jumping on the Elasticsearch bandwagon. Please stick to a SQL database for your invoices. So again, we go back to eventual consistency or true consistency. Pick two. You can't have all three. So there's no cheating. If you want consistency, you'll have to live with latency. Or you need to think about when designing your environment that latency is a true thing. So a few things, ChatGPT, thank you again for just writing a few things, but there's things, latency, it's a killer. It's a user experience killer. I read a paper a couple of years ago where they said every 100 milliseconds of additional latency on an e-commerce web shop reduces the conversion ratio. So imagine if you're on a web shop and you want to browse through items and photos of this object. If it takes much longer than you wanted, then you're not going to buy. You're going to go to a different shop, which is just much quicker. This is all latency. It's not about bandwidth, about latency. How snappy can the application be? And this starts at the lower end, at the fiber optic cables, about planning your infrastructure, planning your Ceph environment, your CloudStack environment, making sure that you have proper latency for your use case in your environment. So it depends per use case what an acceptable latency is, but it starts with thinking about latency before we start thinking about bandwidth and about other things. So latency, it kills the user experience. So what does it have to do with Ceph and CloudStack? Well, I already told a few things, but I have something which happened a while ago, but there was a talk from Florian Haas back in 2019 about a stretched Ceph cluster over Barcelona. It was a hypothetical situation. So you would stretch a Ceph cluster over Barcelona and you have dark fibers running between them. That is feasible if you know how long the path is going to be and if you control the path. But I had a real life experience with somebody who was building such a stretched Ceph cluster. So a single Ceph cluster stretched over multiple sites, but you need to make sure that you have the shortest possible fiber optic length between these locations. So within a city, that could work depending how big the city is. But building stretched Ceph clusters becomes very much impossible when you have to really start dealing with latency and the speed of light. So a real life situation which happened to a company in Germany, which I helped a couple of years ago. So we built this Ceph cluster within the same city, and it was pretty close to each other, these three data centers. Latency was fine. It was 100 microseconds between the locations. Performance was acceptable for what they wanted. And a couple of months later, they gave me a call. They said performance is just dramatic of our Ceph environment. It's not working anymore. And they just couldn't notice what was happening going on. Ceph was no warnings, nothing going on. The only thing was that there was some maintenance on their dark fiber, but traffic was rerouted and the dark fiber came back again. After investigation, we found that they rerouted their dark fiber, really weird route, added like 25 kilometers of distance to that dark fiber. So one piece of the Ceph cluster had just a longer cable. Replication going on there would take longer. Since Ceph is synchronous, performance just dropped down like with 50 to 60% of performance reduction of the Ceph environment. So if you want to do a stretched environment, make sure you control the physical part as well. Think about layer one, because you cannot solve this by just using faster switches or faster routers. It's latency, it's the speed of light. So Ceph can do a 4K write in about 0.7 milliseconds. So you can get about 15 or 1428 IOPS in a single queue with a 4K write if you benchmark this with a 10G network. And I have other talks about this on YouTube around there. I gave many talks about this already in the past. That's the performance you can get because there's a lot of things going on within Ceph, synchronization between nodes, CPUs doing all kinds of stuff. I won't go into all the details, but this is about the performance you can get and lowering. If you just start adding network latency, your performance will just go down consistent with the latency you're adding to the environment. So cheating, there's no way around cheating with Ceph either. So if you want to have consistency, you can stretch it over data centers, but live with the latency, or you can use RBD mirroring, but that's going to be asynchronous, eventually consistent. So think again about that you have this database with payments. You say, we're going to switch to our disaster recovery sites. And if you're a company like Adyen doing so many payments in 5 minutes, we just lost 5 minutes of payments. That's fine, right? Yeah, yeah. I guess not, but that's the reality. So think about it. Think about it. So, but what about CloudStack? Oh, CloudStack itself is less impacted by latency than Ceph is, but of course, the latency between a hypervisor and your storage is important as well. So we have been talking about latency within a Ceph environment, but think about the latency you have from your hypervisor to your Ceph cluster, because that also influences the performance the virtual machine is going to get. But applications within CloudStack, within the KVM hypervisor or some other hypervisor, are of course affected by latency. Again, if you're going to be using something with synchronous writes, think about all the latency between all the different parts. If this VM runs in one city, the other city, you're going to be waiting here for a much longer time. RE2B, same slide again. So the distance between the nodes really matters. Redis, it's the same. Elasticsearch, it's the same. It's a great database, eventually consistent, but keep in mind that it has a problem. So my main things in 45 slides, that's very quickly, right? My main thing is awareness. That's the only thing I want to raise here. It's often forgotten that layer 1 and layer 2 are very important when designing a network and thinking about. We're all used to just going to an API, requesting a virtual machine and deploying applications, and then we start blaming the cloud guys that it's not performing, or it's always the storage, and then the storage said, it's always the network. No, you have to work together to making sure you properly benchmark and think about the choices you make on designing something. What I see happening a lot of times is that the network team comes up with a design and the rest of the organization just has to live with how the network team designed it. So the storage team just gets a rack assigned where they need to put their storage, and that's it, because that's the company policy. If you don't think together with the networking team and the storage team and the cloud team when building this environment, you're going to have a disconnected environment which is not getting the performance you probably wanted or you could potentially get out of it. So awareness. Think about this on every different layer. And there's a few things I wanted to add there. So how you can deal with latency in CloudStack using affinity rules. So some virtual machines, let's say you have a Redis database and a web server. Using affinity groups, you could say, well, I want these virtual machines to run on the same host. OpenStack can do this as well. Any modern orchestrator can do this. Just putting them together, you take away the network latency, and that just gives you better performance. And some others need to go on a different host. So the two different web servers go on different hosts, but be aware, the latency going from B to A, there's latency. And we all talk about microservices. It's great, it's awesome, it's super cool. I agree. It's only wine? Oh, fine. It's French wine, isn't it? No, not yet. No. Anyway, so we all think about there should be an API between the database and the website because that's what we do, API first, API driven. I totally agree. But the website is talking to an API, so microservices. So we have a web application in a container somewhere, an API in a container, and then a database in a container. Network latency, and again, network latency. So guess which one is faster? Yeah, of course. No, I do agree with you. But the thing is that if you do not control where this application on which host it runs on a different host, Yeah. There's many factors here, and again, this is about awareness, raising awareness that latency is a real thing. That adding anything in the stack adds latency, and that's difficult to overcome. Even logging within Ceph, if you turn off the logging, because just writing a log line in memory, just having the CPU spending time on generating this log line adds latency. It happens in the IO request. So disabling logging helps. And I found this one where somebody benchmarked, I think it was in Java, but log4j, how much time it would just add, latency it would add by just having log4j in there and writing a log line. Again, it's not much, but it's again awareness, thinking about the fact that if you're gonna build this if statement and say I'm gonna write a log line, if this needs to be a high performance application, well, it has implications. And I think this morning you were talking about 1.3 million requests per second. If every request would take 10 microseconds additional, well, think about the amount of CPU time you're going to be using in addition. Yeah. So then we say a faster CPU, faster CPU. Let's get a faster CPU. And that doesn't always mean that you're going to get a lower latency, because that's what they say. Well, we'll just go somewhere and we'll take a faster CPU, or take the AMD Epic with the F at the end, which are 10K per CPU, because that's the easiest. I would say just be aware that a faster CPU, there's still network latency. There's all kinds of other latencies happening in there. And again, it is awareness. So we sent rockets to the moon, with this very old CPU. And sometimes it feels like people are building environments while they still have the anchor out and trying to sail their boat, and just adding more horsepower to the boat so they can drag the anchor around, and because that's easier. So my talk is not going to say what you need to do. It is about raising awareness that latency is real. Think about it when designing any environment, storage-wise, CloudStack-wise, anything. It's there, and benchmark latency before you start doing anything else. That's the message I want to give you today. Any flames, questions, remarks from the audience? No? Okay, good. Oh, there's one. And you microphone. You need to keep it very close to.
We've been spending a lot of time chasing latency, and you said like 25 gig is supposed to be faster than 10 gig, but you have like FEC and you have a lot of other stuff added to 25, so it's not necessarily true.
No, it's not always true. So this is where you need to do your testing. If you do a one-on-one comparison, you'll see that 25 slightly outperforms 10G, but in a real life scenario, it doesn't make a major difference.
Yeah, but like, what is the switch ASIC? Like, are you using DAX? What's the length? Which optics? Which are you using? Which FEC are you using? Are you turning it off? There's like so many variables.
Yeah, but this is what I mean. You're adding so many things. So there's so many parameters which are influencing latency that it is, again, about thinking about is that it exists. So 25, if you compare, I think it's a direct attached connect cables. So the copper cables, they're 25, slightly faster than the 10G is. Some others say that you need to use fiber optics because that's even quicker within a rack. So many debates about this.
There's so many truths.
Yeah.
And very little lab data. And there's like everybody's saying something, but nobody's proving it.
Yeah, that is true. And what my main message is that latency is there, and trying to circumvent it, be aware that it exists, and live with latency. And developers, please be aware that latency exists when writing code, instead of just asking the team to make stuff faster, because we're reaching the limitations of what we can get.
I think it's good that you're highlighting it, because like people need to talk about it, be aware of it.
Yeah. Other question, remark.
Hi. I would like to just
a bit closer. Yeah.
Sorry. I would just like to add that I think you should always be aware of the costs of premature optimization. There's lots of places where you can get really deep in the weeds to get every last microsecond of latency ironed out of the stack. But it can be very difficult to ensure that those things are consistently done every place that they need to be done to get consistent results. So small changes that are difficult to audit can come back to bite you at times.
I think that's a very good remark. So tuning because you want to tune, don't do that. So it needs shaving off a microsecond because theoretically it should be faster. Do you really notice it in the end? So benchmarking your end application, what you're running, instead of and knowing what's going on, but be aware that latency is something you cannot neglect and just not think about.
So if you're going to do that, and there are good cases for doing that, then you should make sure that you have monitoring in place to catch when that stops being the case. Like we've seen something as innocuous as a kernel update on one Ceph storage node suddenly produce drastically different results from what it did before the update.
Yeah, that's good feedback. Okay, no more questions. Then again, thank you, and we can go to the next talk.